Hey everybody, hope you're having a great day. Today we are going to talk about surface area of pyramids and cones. So one thing that I added to Schoology today is I added a formula sheet. So what we can do is we could actually start by filling in this formula sheet. So if you didn't fill yours in yet, you could start to, and then as we learn more, we'll add them. Okay, so if you could print yours out, that'd be great because then you could have it to the side. If not, just open up yours in Schoology and copy them down. Okay. I don't know if you can double take task and write at the same time that I'm writing. You might have to write them on a separate sheet of paper. All right. So these first 8 are from the last chapter, but you need them since they're included in these figures that we're working with. So remember, area of a square is area equals side squared. Rectangle, base times height. Parallelogram, base times height, area of a circle, pi r squared, area of a triangle, 1/2 base times height, trapezoid, 1/2 base 1 plus base 2 times height, regular polygon, 1/2 apothem times perimeter, and then circumference is 2 pi r. Okay. So it says this formula sheet cannot be used on the test. Can be used on the test. So this formula sheet you can use. We're going to provide you a formula sheet for your final exam. It's just that this one wasn't allowed to be used when we were in class on the test. Okay, so prisms and cylinders we learned on the last set of notes, so let's just fill these in really quickly. Lateral area of a prism, then there's an example of a prism that's a rectangular prism, is perimeter times height. And then total surface area is perimeter times height plus 2 times the area of the base. So now notice at the bottom here, I also have what these letters represents, so we make sure that we understand that. So B is area of the base. P is perimeter of the base. Okay, and then L, H, and R we haven't gotten to yet, so let's not worry about that just quite yet. All right, lateral area of a cylinder, 2 pi RH. Total surface area, 2 pi RH plus the 2 circles on the top and bottom, 2 pi r squared. So L still haven't gotten to. H is height, which we did get to, so I don't know why I said we haven't gotten to that yet. So H is height of solid, we'll put. And like it's the height of the prism, the height of the cylinder. R is radius of the circle. Okay, so let's get to today's notes. And today's notes will be adding cones and pyramid surface area. I actually removed spheres from the lesson for time-wise, for e-learning time-wise, but we'll add that formula to this also when we get there, just so that you have it. So it's not like you've never seen it before. Okay, today's notes, surface area of pyramids and cones. So first, vocabulary. What do we think this is called right here? Vertex, correct. This right here, so notice it goes from the vertex to right in the middle of the prism, right here. Sorry, not prism, pyramid, right here. That is the height. So notice that it is perpendicular to the base. It is a vertical distance, okay? That's what the height is. Okay, next, this height right here. Okay, this is, now I just called it a height, kind of gave it away, but that dashed line right there. Now that is not the height of the pyramid because it's on a slant. So this is actually called slant height. Now we can do this right here, but the variable for height is h. The variable for slant height is lowercase cursive l. Okay, so that's slant height. That's what it's going to represent. All right, the next one, let me change colors here so you can see what it's pointing to. What it's pointing to is it's pointing to this, which is the same thing as one of these, which is the same thing as this right here. Those are all lateral edges. The next one is pointing to this entire part right here. So like there's 1, 2, 3, and then you don't see what I'm counting, but like 2, 3, those are all your lateral faces. Oops, faces. All right, this right here is pointing to what? So notice it goes from the center, comes down, hits at a midpoint. So if you want to draw this, oh man, I'm trying real hard to draw that. If you wanted to draw this pentagon here, it's asking what's this called right here. You know what that's called. It's called an apothem. And then last but not least, this arrow right here is pointing to the bottom, which is the base. Okay, so that's your vocab for your basic parts of a pyramid. All right, next, let's talk about the formula for lateral area. So for lateral area, which is all of the triangles on this pyramid, just not the hexagon, or sorry, that's a pentagon on the bottom. So all 5 of those triangular faces, that's what the lateral area is. The formula is 1/2 the perimeter times the slant height, okay? I have that lowercase l as slant height right here, so I'm not going to write it down again. Okay. I don't know why it says what's the formula for area of a triangle. Okay. Next, to find, well, I know why. It's how I explain the formula for lateral area, but let's not worry about that. Okay, so to find the total surface area, so we would, like this formula right here is to find all of those triangles. If we want to find the total surface area, that's everything we can touch, so we'd have to include the base. So the total surface area is just the lateral area plus the area of the base, which is capital letter B, remember. Okay? All right, so here's our first example, finding surface area of a pyramid. All right, so find the surface area of a rectangular pyramid. So this right here is telling us that the base is a rectangle with length 11 meters and 18 meters. So it's telling us those two lengths of the base, and a slant height of 26 meters. So first things first, I always say to everyone, what should I do first? And they say, draw a picture, okay? Now, if you think about it, if I had to find the lateral area of a cylinder and I gave you radius and height, do I have to draw a picture? No. So what I'm going to do first is I'm going to write down the formula and then decide what I need to draw, because I don't want to get extensive with this and go crazy and draw a 3D figure if I don't have to. Really quickly, just to like throw it out there, you're never going to have to actually draw the whole 3D figure. You're always going to draw the base though, because that's what you need. You need the perimeter of the base. You need the area of the base. Okay, so let's get started on this and me stop babbling. So surface area of a pyramid, I'm going to write down the formula. Total surface area is equal to 1/2 of the perimeter of the base times the slant height plus the area of the base. Okay, so I'm going to write T equals 1/2. I'm going to leave a space for perimeter. I'm going to leave a space for slant height, and then I'll leave a space for base. All right, did I give you the perimeter of the base? Well, there is no base drawn, so we want to draw the base. So I'm going to draw the base, which is a rectangle. Just do that in purple since I underlined it in purple. It's a rectangle, and it has a length of 11 meters and a width of 18 meters. Now, my bottom piece looks longer than my my height piece looking thing. So you can switch them or you can keep them where you are. It doesn't, like, it's not to scale, it's your representation, but I have OCD, so I'm switching them. Okay, so now I'm going to find the perimeter of that base. So perimeter, I'm going to add up all the sides. There's 2 sides that are 11, plus there's 2 sides that are 18, and that's going to give me my perimeter. So my perimeter is 58 meters. Plug that in right there. All right, now I need slant height. Did I give you slant height? Yes, I did. It's 26. Fill it in. All right, now I need area of the base. Here's the base right here. I haven't found the area yet. Area of a rectangle is base times height, or length times width, 18 times 11. So we get the area of the base is 198 meters squared. 198. All right, I'm ready to pick up my calculator to get my total surface area. I like to do 0.5 times 58 times 26 plus 198, okay? Or you can do 58 times 26, enter, divided by 2, enter, plus 198, enter. That's just more work. But you should be getting 952 meters squared. Remember, this is total surface area, so it's meters squared, okay? If you're not getting 952, send me a message, and I will, with a picture maybe of your calculator screen, I can help you out. All right, next one, surface area of a pyramid. What kind of pyramid? Square. All right, total surface area. 1/2 perimeter times slant height plus the area of the base. All right, 1/2, I need the perimeter of the base, I need the slant height, and I need the area of the base. Okay, so perimeter of the base. So here is the base. It is a square. I like to draw it separately, but you can clearly see the base there. So this is 10 meters, and since it's a square, they're all 10, right? Okay, so first thing they asked me to find is, or not the first thing they asked me, the first thing I have to find is perimeter. Add up all the sides. There's 4 sides that are 10, so the perimeter is 40 meters. Slant height. Did I give you the slant height this time? Nope. Okay, so this I want you to pay really good attention to. This 12 right here is actual height. I want slant height, so I'm going to draw slant height in. To draw on slant height, I'm going to make a point at the vertex, and I'm going to make a point directly in the middle of one of the sides of the triangle's bases, or one of the sides of the base. Okay, and I'm going to connect those two, and that's slant height. Okay, I want to find that, which is x. So notice with this piece that's 12 right here, it is almost forming something that we recognize. All we have to do is connect those two pieces, and we have a right triangle. And I know that's perpendicular because that's the height. Now, do I know this piece length right here? The answer is yes. Realize it's this length right here that I'm looking at. That's 5 meters. So I can put in the 5 meters here. So now how can I find x? And my Notability froze, per usual. How can I find x? We know the answer to that. It's Pythagorean theorem. So I'm going to do 12 squared plus 5 squared equals x squared. 144 plus 25 equals x squared. 169 equals x squared. Square root, remember, I don't have to do plus or minus only because this is a length, which has to be positive. So that is 13 meters. I could have called it L if I wanted to, since it's slant height. It doesn't matter, though. All right, 13. All right, last but not least, I needed to find the area of the base, which I haven't done yet. So I'm going to come back down here to the base. It's a square, so side squared. The area of the base is 100 meters squared. I'm going to put that in my calculator, 0.5 times 40 times 13 plus 100, and I get that the surface area is 360 meters squared. I am not showing an excessive amount of work here. This is the minimal amount of work here. Imagine having a wrong answer here, and I have no idea where you got it from. Imagine having a wrong answer here. This is where my work is. I have no idea where you got it from. Imagine having an answer right here, and I have no idea where you got it from. Here's my work for that. For this 40, here's my work for that. You need to have work for those numbers unless it's given to you. Okay, so if it said slant height is 13 right here, then you don't need work for the 13. Okay, next one. Find the surface area of the regular hexagonal pyramid. So surface area, once again, T equals 1/2 perimeter times slant height plus the area of the base. Okay, so I like to, as you can see here, make a skeleton of everything that I need. And I just put that line there because so I realize it's something needs to go there, right? Okay, so P is perimeter of the base. So here's my base. Okay, it is 1, 2, 3, 4, 5, 6. It has 6 sides. It says it's regular. So I know that I can find the perimeter. Okay, I'm going to redraw it only because you'll see that I clearly have to find the area later. Okay, so perimeter. These are all 12, right? So there's 6 sides that are 12. So the perimeter is 6 times 12 is 72. So I can fill in that 72 right there. Next, I need slant height. Okay, so let's look carefully here. Did I give you slant height? The answer is no. The answer is no. It's not 10. Now, I can understand why you think it's 10, but remember what I told you. It goes from the vertex to the middle of one of the sides. This is not the middle of one of the sides, right? So I'm going to draw in slant height. And I'm going to call that X again, or you can call it L. And then once again, you can say, ooh, that's a right angle. Do I know this? Realize that's the same thing as this right here, which is half of 12, which is 6 feet. So 6 feet. Do I know this? Yes, it's 10. So I can use Pythagorean theorem once again to find slant height. X squared plus 6 squared equals 10 squared. X squared plus 36 is equal to 100. Subtract 36 from both sides. X squared is equal to 64. Square root, once again, I don't have to do plus or minus because this is a length, so it has to be positive. And now I know the slant height is 8 feet. So once again, please don't just put numbers there. I need to see this so I know where it came from. All right, last but not least is the area of the base. So I have to find the area of this figure. We did this last chapter. I'm going to go through it somewhat slowly, but remember we did do this last chapter. Okay, so area of the base. What is this? This is a regular hexagon. So 1/2 apothem times perimeter, which notice it's also on your formula sheet. 1/2. Do you have the apothem? No. So I'll leave a big giant space for apothem, remember. Do I have the perimeter? Sure do, I already did it. It's 72. Okay, so now I need to find the apothem. Remember what we're going to do here. I'm going to put an A here for apothem, and I'm going to make this into a right triangle. I already know this is 6, that's good. Now I'm going to end up using SOHCAHTOA, but I have to find that angle right there. So to get that angle, I'm going to do 360 divided by the number of sides, which is 6, and then divide that by 2. So I end up getting that this angle is 30 degrees. Now I'm going to see if I use sine, cosine, or tangent. This is opposite, this is adjacent. So we're using tangent to find A. Tangent of 30 degrees is equal to opposite, which is 6, over adjacent, which is A. Put this over 1 so you can cross multiply. A times tangent of 30 is equal to 6. Divide by tangent of 30. Divide by tangent of 30. So you get your apothem is 6 divided by tangent of 30. All right, so now I'm going to put this in my calculator and see what my base is. So I like to do 1/2 or 0.5. I like to do 0.5 times 72 because that's just like a normal looking number. Then I like to do parentheses. 6 divided by tangent of 30, close the parentheses, enter. Okay, before you write down this answer, is this my final answer? No. I still need to find total surface area, right? So since it's not my final answer, I'm going to write down 4 decimal places so I don't accidentally round too soon. 374.1230. Does this say where to round to? No, it doesn't, but it should say round to the nearest tenth. I know what your test says, right? I know what your final says. Okay, so now I'm going to put this whole thing in my calculator, and I'm going to round this answer to the nearest tenth. So go ahead and try that. You can pause if you don't want to check it yet, but it's not going to hurt you to see what you're supposed to get, and then just look at your calculator and make sure you got that. 662.1 feet squared. Okay, so what I want you to notice is that knowing the last chapter is still really important. So these two chapters coincide with each other. And it's nice because if you've been keeping up with the last chapter, this chapter, as long as you like have the formulas in front of you, it's not too bad. Okay. This one right here is pretty easy. The lateral area of a regular, but it seems more difficult, right? The lateral area of a regular pentagonal pyramid is 150 centimeters, and the length of each side of the base is 6 centimeters. Find the slant height. Okay. So lateral area of a pyramid. So I'm going to write down the formula for lateral area of a pyramid. Remember, it's lateral area, so I'm not doing plus base. Okay. So they gave me the lateral area of the pyramid's 150 equals 1/2 times perimeter. Did they give me the perimeter? Well, they told me that it is a pentagon and all the sides are 6 and it's regular, so they're all the same. So I have a 5-sided figure because it's a pentagon. Oh, geez, that's not the greatest pentagon I've ever seen in my life. And all sides are 6 centimeters. So what is the perimeter? 5 sides that are 6, the perimeter is 30 centimeters. So that's times 30, and it says find the slant height, so I have to solve for L. So this is probably our easiest one. I just want to make sure you know how to do the math. So first thing you're going to do is you're going to get this to be one number, okay? Because right now it's 2, it's making it more confusing. 150 equals, what's 1/2 times 30, or what's half of 30? 15 times slant height. And then how do I get slant height by itself? How do I get L by itself? That's multiplication. So divide by 15, and I get my slant height is 10, and I need my units. This is not centimeters squared. Is it centimeters or meters? It is centimeters, my bad. Okay. It is not centimeters squared because this is the slant height. This is the length. So it's just centimeters. Okay. All right. So the last figure that we have to talk about today is a cone. Okay. So let's look at the basic parts of the cone. This right here, we know what that's called. That's a vertex. This right here goes from the vertex to the center. That's the height, which is h. This right here is the slant height. It has no edges, so if you're like, wait, that's an edge. There's no edges on a cone. Slant height. This right here, what's that called? Radius. Whoa. Which is R. And then this, what it's pointing to right here is this whole thing right here. This is the base. Okay, so let's get our formulas for a cone. So our lateral area of a cone is pi times radius times slant height, pi RL. Total surface area is the slant height, pi RL, plus, and then there's only one area of a circle to add to this, so plus pi r squared. Okay, find the surface area of the cone. Total surface area of a cone, pi times radius times slant height, plus the base, which is a circle, so plus pi r squared. Also, no directions on how I want your answer here, so I'm going to write them in. Keep your answer exact. Okay. All right. Pi times radius. Do I have the radius? Yup. 16. Times the slant height. Do I have the slant height? Yup. 34. Plus pi times radius, which was 16 squared. Okay, so now I have to get my exact answer. That means I'm not putting pi in my calculator. So first I have to simplify this. I'm just going to do 16 times 34 in my calculator. And I get 544. And then remember, I never put the pi in my calculator. Plus, I need to know what 16 squared is. And once again, I'm not putting pi in my calculator. So 16 squared is 256. And I didn't put pi in my calculator. So now notice these both have pi in them. It's like having like terms. I can combine them. So 544 and 256, once again, I'm not putting pi in my calculator, is 800 pi centimeters squared. Okay. Now, really quickly, sidebar, if this was 544 pi plus, and then it was just 256, not 256 pi, these I could not combine without using my calculator and getting a decimal answer and putting pi in there. But once this has a pi in it, it's like they're like terms, and I can keep pi in the answer. Okay, next one. Find the surface area of the cone with radius 8 centimeters and height 15 centimeters. Give an exact answer. Okay, so the directions are there. Surface area, cone, T equals 1/2. Oops, I'm just accidentally doing pyramid. It's not 1/2 pyramid times slant height. It's pi RL plus pi R squared. Okay, so I need pi times, did I give you a radius? Yes, I did. Radius is 8. Did I give you slant height? No, I gave you height, so I don't have slant height. Plus pi times 8 squared. All right, so I need the slant height. Okay, so I might want to draw a sketch here to help myself out. So here's a cone. The only thing you're ever going to have to sketch is a cone, and they're pretty easy. Just draw a circle and then connect it. Okay, so I gave you the radius, which is right there, is 8 centimeters. I gave you the actual height, which is right here, is 15 centimeters. I need the slant height, which is right here. So how do I find that? Pythagorean theorem. 8 squared plus 15 squared equals slant height squared. You can have x there. 64 plus 225 is equal to L squared. 289 is equal to L squared. Square root, once again, plus or minus not necessary because it's a length. And you get 17 centimeters. So this is 17 centimeters. Put a 17 there, and now I'm ready to get my exact answer. So I'm going to get this exactly. So I'm just going to do 8 times 17 in my calculator, which is 136, and I didn't put pi in there, plus 8 squared is 64 pi. They both have pi in them, so I can combine these two numbers, which is 200, and then I didn't put pi in my calculator, centimeters squared. Okay, so we have one left, and then the rest was just like you tries. So I'm not going to end up doing those because it's, it's excessive here. Okay, so the next one is find the surface area of a cone with a base circumference of 25 pi inches and a slant height of 3 inches. So I want to find the surface area of a cone. So I'm going to write down my formula. Total surface area equals pi RL plus pi R squared. Total surface area equals pi times, did I give you the radius? No. Did I give you the slant height? Yes. Plus pi times, I didn't give you the radius. So now I need the radius. Now, if I look at this, to find the radius, I would need the slant height and the height, which I did not give you, like to use Pythagorean theorem, but I did give you this information, circumference. So what I'm going to do is I'm going to write down my circumference formula. Circumference formula, you can look at your formula sheet if you forgot it. It's 2 pi r. I'm saying I must put a square there. There's no square there. So that is 25 pi equals 2 times pi times r. So now what I'm going to do is I'm going to solve for radius because I can solve this equation for r. First thing I'm going to do is divide both sides by pi to get rid of this pi right here. So now I have 25 is equal to 2 times r. Divide by 2, and I have my radius is 12.5 inches. So now I can take 12.5 and plug it in here and here. Once again, let's get an exact answer. So I'm going to do 12.5 times 3 in my calculator. And I get 37.5. I didn't put pi in there, plus. And I'm going to put 12.5 squared in my calculator. And I get 156.25 pi, because I didn't put pi in my calculator. And now, once again, since these both have pi in them, I can combine them and leave pi in my answer. So I'm going to add 37.5 and 156.25, and I get 193.75, don't forget pi, inches squared. Okay, so that's it for notes for today. What I am going to do is I'm going to go back to my formula sheet and add my formulas. Once again, cone, lateral area, pi RL. Total surface area, pi RL plus pi r squared. Pyramid, lateral area, 1/2 perimeter times slant height. Total surface area, 1/2 perimeter times slant height plus the area of that base. Down here, I can add what lowercase cursive L stands for. Once again, that's slant height. Okay, now I am going to add sphere here. I'm torn on whether even to throw one on a review for you. But hey, why not? Actually, you know what? I'll do surface area of a sphere and volume of a sphere at the same time, and I'll do it last. Okay, so we'll save that for today or for next time. All right, so go ahead and get started on your homework. If you have questions, please feel free to contact me. But look back, rewind these notes, look at things